Let's assign oxidation states to everything that we see in these reactions. Now we will analyze each reaction, figuring out what is reduced and oxidized in them. In the first reaction, iron is oxidized and hydrogen is reduced. In the second reaction, we see no change in the oxidation state of sodium and sulfur. So no oxidation and no reduction. The story repeats itself in the third reaction. We see no change in the oxidation states of elements. And in the last reaction, iron is reduced and nickel is oxidized. So what conclusions can we make based on our observation here? Well, not every reaction is redox reaction. That's all. Many chemical reactions are redox reactions, reactions of synthesis, decomposition, single replacement, combustion. They are all examples of redox reactions, but double displacement reactions are usually not redox reactions. And the reaction of neutralization, which is a case of double replacement reaction, is also usually not a redox reaction. To identify redox reactions here, you can look for the classical redox reactions such as single displacement, synthesis, decomposition, or combustion. Or you can assign oxidation states to everything that you see in these reactions and see which one has the change in the oxidation states. Now look at the second question here and identify redox reaction. In reaction number 4, we can see oxidation of copper and reduction of silver. This is our redox reaction. Same assignment over here. While we're looking for the redox reaction in the first question, we can immediately cross out equation number 1 and 3 because number 3 is a double replacement reaction and the number 1 is the reaction between acid and base. It's neutralization reaction, so it's a case of double displacement. So in those two reactions, we do not expect any change in the oxidation state of the elements. So we will be choosing between reaction 2 and 4. And if we assign all the oxidation states there, we'll see that only in the reaction number 4 there is a change in the oxidation state of iron. Iron is getting oxidized and sulfur is getting reduced. In the second question over here, we would glance at the reactions and probably would see right away that the reaction number 1 is a ticket to answer this question, because we can see that there is an elemental oxygen with the oxidation state of 0 on the left, and oxygen on the right side of the equation is part of the compound. It means that the oxygen is changing its oxidation state from a 0 to a -2. And if we assign the rest of the oxidation states, then we will see that carbon is getting oxidized. Besides, this equation number 1 over here is a reaction of combustion, which is always redox reaction. Pause this video and identify oxidation and reduction reaction over here. I vote number 1 reaction to be the oxidation reduction because I see elemental chlorine on the right and my chlorine on the left has a charge or oxidation state of -1. So there is definitely something being oxidized and manganese was reduced.